look at what does the graph y equals 5 look like. So that's really what I want to do. I want to sketch what that curve looks like. So what does y equals 5 look like? That's just simply a what? Horizontal line. So the area that I want to find between the x-axis and that horizontal line of 5 is going to go from an x value of -5 to 7. So again, I've got my lower bound of -5, my upper bound of 7. What shape is formed? A rectangle. So we all know how to find the area of a rectangle. The area of a rectangle, I know, is just simply length times width. So what is the length of this rectangle? What's the distance from -5 to 7? 12. Times, what's the height? The height is going to be 5. So 12 times 5 is 60. So one way I can calculate the area is to actually sketch the region and then use an appropriate geometry formula. So any questions where I got 60 units squared for the area? Now let's take a look at B. We mentioned this a while ago when we were talking about our Riemann sums. What happens when that area appears under the x-axis or below the x-axis? What do we consider that area? We consider that area to be negative. So let's take a look at B. So B is, again, the sine of x from -π/2 to π/2. So I know that the sine of π/2 is 1. So I know that this region is going to look something like this. So again, I'm trying to calculate the area from 0 to π/2. Then I also have the region from -π/2 to 0. Well, where is the region -π/2 to 0 going to be located for sine of x? Is it above or below the x-axis? Below. Because I know from -π/2 to 0 that sine is negative. Well, do you agree with me that these two regions are symmetrical? Yes. So what would this area then be? This area is simply going to be 0. Because again, remember, this area is negative, this one's positive, so they end up canceling each other out. We will talk about absolute area where we'll take the absolute value later on. All right, so any questions on B? Now let's take a look at C. So we know absolute value functions in the shape of a V. So the question is, when I want to calculate the area under the curve from -2 to 0, first of all, what we want to do is at these particular endpoints, we want to find the y values. When I plug 0 in for x, I know the absolute value of 3 times 0 plus 2 is going to give me 2. When I plug in -2, 3 times -2 is -6. -6 plus 2 is -4, and then the absolute value of -4 is going to give me a 4. Now the question is, when dealing with the absolute value, where is the vertex of this particular absolute value function going to be? -2/3. So what this absolute value function looks like, it's going to hit the x-axis at -2/3, and then it's going to come back up. Remember, with absolute value, to identify the vertex, the coefficient of x needs to be a positive 1. So you factor that 3 out, and that's going to give you x plus 2/3. So to identify that horizontal shift, remember, of the absolute value function, or any function, the coefficient of x needs to be 1. So we factor the 3 out, and then that shows you that shift to the left 2/3. So everybody okay on why it's hitting the x-axis at 2/3? So now what two geometrical shapes am I dealing with? I'm dealing with two what? Triangles. So if I can define the area of triangle 1, I can add it to the area of triangle number 2. So the area is going to be equal to, and again, I know the area of a triangle can be found by 1/2 base times height. So 1/2 times. Let's take a look at the base of triangle number 1. What is the base? Well, what's the difference between -2/3 and -2? That's going to be what? It's going to be 4/3. Times the height. What's the height of this first triangle? That's going to be a what? 4. So I'm going to add that then to the area of my second triangle. So 1/2 times a base of 2/3 times a height of what? 2. So 1/2 times 4/3 is going to give me 2/3. 2/3 times 4, that's 8/3, plus 2/3. So we should end up with 10/3 as my area. So any questions on calculating the area? Again, you can just divide them up into geometrical shapes and add them together. Let's take a look at D. Calculating the area under the curve from 0 to 3 of the square root of 9 minus x squared. What shape is this going to be? Well, if y is equal to 9 minus x squared, any thoughts on what this shape is going to be? Oh, how would I get rid of the square root? What could I do to both sides? Square it. So y squared is equal to 9 minus x squared. Looking familiar yet? X squared plus y squared equals 9. What is this? It's a circle. And where's the center of the circle? The center is at 0, 0. My radius is 3. So now, be careful about the circles, guys. I know my radius is 3 and my center is at 0, 0. Now, I'm only going from 0 to 3 along the x-axis. My question to you is this. How much of the circle am I seeing? Am I seeing this whole circle? Because wouldn't you agree with me that this goes from 0 to 3 for the x value? So my question to you is this. Am I seeing half the circle? Or am I seeing a quarter of the circle? Interesting. Why? I'm hearing some of you say a quarter. Why just a quarter? Square root, exactly. Because what was inside the radical? It wasn't plus or minus square root, it was just the what? Positive. If I had done this, which part of the circle would I have seen? Not the top part, but I would have seen just the bottom part. If I did plus or minus, then I would have seen the whole part. You've got to be careful with the circles. All right, so does that make sense on why we're only looking at the top quarter part of the circle? So we're only looking right here because it all goes back to the square root. So I'm only calculating the area in the first quadrant of the circle. So how much of the circle is this? 1/4. So the area is going to be 1/4 pi r squared. So the area of this circle is going to be 9 pi over 4. So any questions on letter D with the circle? All right, let's take a look at example 2a. So here's a lovely piecewise function that you guys love oh so much. Yes, Izzy? Oh, yeah, unit squared, yeah. So piecewise function, so we've got an absolute value function for x values less than 0, and then we have our constant function of 1 for x values greater than 0. So I want to calculate the area under the curve from -1 to 0. So when I plug -1 in for x, -2 minus 1 is going to give me a 3. But now when I plug in a 0, 0 minus 1 is -1, but the absolute value is going to be 1. My vertex is not hitting the x-axis. Nowhere between -1 and 0. Is this a triangle? No, it's not. So what you may have to do is take this region and to divide it up into two other type of geometric shapes. Does anybody see what type of shapes I could divide this region into? A rectangle and a triangle. So I can draw a rectangle with a height of 1. So I can add those two areas together. So I can take the area of the rectangle and add it to the area of the triangle. So the area is going to be 1/2. Let's talk about the triangle first. The base is 1. What's the height of that triangle? 2. Plus, the area of the rectangle is simply going to be base times height. So that's going to be 1 times 1. So what's the area of the area under the curve for this particular function? It's going to be what? 2. You guys go ahead and try B for me. Area under the curve. So let's take a look at A. So what is the area between the curve and the x-axis for the region A to B? This is labeled as what? 10. So here's A to B, and they pointed area as 10. So now let's look from B to C. So starting here from B all the way to C. Now again, this one region is not above the x-axis, but it's below. So what are we going to state that this area from B to C is going to be? This is going to be negative 94, because again, it's falling below the x-axis. So then to calculate the region from A to C, again, we know that A to B is 10. We know from B to C is negative 94. So what's the area under the curve from A to C going to be? This is going to be negative 84. And then letter D, from A to D. All you're going to do is add those different regions together. So from A to B is 10. From B to C is negative 94. From C to D is 9. So 10 minus 94 plus 9 is going to give me negative 75. So like I said, sometimes they'll divide your areas up and you just have to add or subtract them. All right, last two problems. Find, again, the area under the curve from negative 1 to 6. If your area from 2 to negative 1 is 7, and from 2 to 6 is 5. So really what I usually do when I see a problem like this is I kind of write an integral equation. The whole region is what I'm trying to find from negative 1 to 6 of f of x dx, correct? So looking right here, they're telling me the area under the curve from 2 to negative 1 is 7. So right here, notice my upper bound is smaller than my lower bound, or think of it as going backwards. So what I'm going to do is I'm just going to negate this and rewrite my bounds as going from negative 1 to 2. So to calculate the area under the curve, if I can find the area from negative 1 to 2 and add that area from 2 to 6, that would give me that whole entire region from negative 1 to 6. Well, this is what I'm trying to find. So I'm going to call that y. Equals. They told me what the area under the curve from 2 to negative 1 is equal to. That is 7. But since I rewrote my bounds, I'm going to call that negative 7. Plus, they told me the area under the curve from 2 to 6 is 5. So then what's the area under the curve from negative 1 to 6 going to be equal to? Negative 2. You guys go ahead and try B for me. So remember, guys, the whole entire region is from 0 to 10. But notice that upper bound is smaller than the lower bound, so I need to negate this. So my lower bound and upper bound are in the correct position. And I'm going to set it equal to the area under the curve from 0 to 6, which is what I'm trying to solve for, and then the area from 6 to 10. All right, so I know 4 is equal to y plus 8. So any questions on the definite integral and using just the area under the curve to calculate the area region? Good? Are we good? Remember, with definite integrals, you're getting numbers as an answer. You don't need to add the c. When do you add the c? You add the c just when you're dealing with the indefinite integrals, when there's no upper bound and lower bound. All right? So any questions on that? All right. So you guys have...